Hello, everyone. I think we should give 1 minute or two for others to join because there are many participants from different parts of the world. So let's wait for 1 or 2 minutes. So now, hello everyone. Good morning, good afternoon, good evening, wherever you are. I hope you hear me okay. And welcome to this COP meeting. We have very interesting session today, and we have. First of all, Dorcas has asked me to host today's session, so I'm here with you all. So we have EBS team today. EBS, if you don't know, I'm sure most of you know, but this is enterprise breeding system, and this is a software system that provides end-to-end support to various breeding operations in various level and helps to manage the breeding database. So it's a complete package for a breeding program. And we're going to hear a lot about it today. Please be patient. So this is the title today. So we'll have overview and we'll learn about the capabilities and future plan in terms of development and adoption as well. Okay, so we have EBS team members who will be presenting Andre Moreto, Marko, Kärkäinnen, Edie and Kate Dreher. So this will be more. This is an information session. So and this will be useful to all of us, especially the CG breeding programs. If you are already using the system or plan to use in the future, so this is an opportunity for you to understand what's going on in EBS. And if you have any questions, please feel free to ask at the end of this presentation, and at the same time, so you can type your question in the chat box. So we'll go through those questions towards the end. Last 20 minutes will be for discussion, and this is an opportunity again for all of you who are using or planning to use this EBS system in the future. So without any delay, and if you have any questions regarding this session or regarding overall this community of practice sessions, any of the sessions, please contact Dorcas Gaminit. Yeah. All right, so I'll stop here and I'll ask the EBS team to share and start their presentation. Please feel free to introduce yourself before you start your presentation. Kate?
Hello. Well, thank you very much. And I think I'll turn it over to Andre to start the presentation.
Thank you, Kate. Thanks a lot, Boja. Thank you, everyone, for having us here today, talking a little bit about the enterprise breeding system. And yeah, as Boja mentioned, it's hopefully and probably a system that some of you, most of you, if not all of you, have heard about. And yeah, also hopefully some of you are already using it or are planning to use it soon, to adopt it soon. I seen the list of people, many names, and that I recognize, and I know that some of you are already using it, have been in contact, or even participate in the program since 2021, when we started with a different setup of the program. But yeah, and as Boja mentioned, in case you need any further information about EBS, about how we work and what's the detailed plan for the coming years, please let us know. Contact us through Boja, through Dorcas, or directly. You'll probably see some contact information during this presentation, so please let us know. Okay. So what we are doing today is just to give you a very brief presentation on the EBS. EBS is much more than what you're going to see today, but we hope that with what we are presenting today, you will get a good understanding about it. So we have a quick introduction, and then we'll talk a little bit more about the technical details of EBS, its capabilities, its tools, its functions, what it supports, and what's coming next in the further rollouts that we'll have for the EBS. Then the adoption process, how it works. I know that sometimes creates a little bit of anxiety, people who are willing to take it or to adopt it or are planning to use it. They want to understand exactly how much time it will take and when that will happen. So you'll hear a little bit about it today as well. And we'll have some time at the end for questions and answers and hopefully a good discussion about today's presentation. So we can go to the next slide. Thank you, Kate. So starting with the basics, what is the enterprise breeding system? What does it do? So I will start with our vision. I think the vision that we carved a couple of years ago represents exactly what we do, what EBS does, and what the EBS team wants to deliver in terms of value. So it's a software that to accelerate development of crops and in global food security. So as Boja mentioned, it's a breeding data management system, and it's a fit for purpose, open source. You don't have to pay a license to use it. It's cloud-based, which means quick deployment and very responsive functionalities. And of course, it is it has a user-friendly interface, and its functionalities are also very user-friendly. These characteristics of the system enable the end-to-end real-time breeding data flow. And our operational data is stored in one single place. We can talk a little bit more about that in the coming slides, because there is a certain limit to the amount of data that is stored. We work with operational data. But we also have a plan. We also have a work being done about historic data. So there is a requirement being addressed related to that right now. And with that, EBS enables network breeding and data sharing across its multiple distinct users. Next slide, please. Yeah, so here you see the two, the two screenshots, just to give an example of what kind of interface the users will experiment while using the EBS. So it's very clean, very friendly, and as I said, very responsive system. Yeah, next slide, please. Thank you. So we've been this year has been very good for us. Overall, we received the green light, the approval from CG for EBS to become in the future the one breeding data management system under CG. We have also started discussions and onboarding the first NARs this year. So what you see on the screen here is a transition that started, as I mentioned, in 2020, 2021. But of course, EBS started as another system called B4R that goes all the way back to the 2010s years, and after CIMMYT and ERI joined forces, that was exactly the moment where EBS was born in 2017, 2018, and from there a lot has happened so far. So we have ERI fully adopting it in 2021. Then we started a transition also from BMS to EBS with some crops within CG. IITA was one of the first to do that migration. Then Africa Rice, and in 2024, our team will start to support some of the BMS users, not all of them, but a limited list of BMS users already preparing to transition into EBS in the future. And we also have plans for the RTB crops. There is a decision pending about whether the RTB crops will migrate to EBS or stay with grid-based or other systems. We have next week work. Marko might say a few words about it to do a detailed study of breed base and ensure that EBS can easily replace breed base if that's the choice of those crop leads and those crop teams. But that's something that is to be decided on. And in the future, as I said, if all goes well, EBS should become the one breeding data management system for the CG centers and the NARS partners. So next slide, please. Here, and I think I like to say a big thank you to our IITA partners, because they have been creating a lot of content in terms of the publicizing the EBS out there. We just had a very successful participation during the APBA conference in Morocco. And this slide that you see here, I reused some of the information that was generated by them for that presentation and for some other presentations that have been doing. But this is just to show a little bit of our goals, some of our main goals. We want to bring together all the data required to enhance predictive breeding and support, which leads to increasing genetic gains, better understanding of G by M, and make it possible for better decisions for the users, for the farmers, for everyone who is involved in the exchange of data by using EBS. Also enable more reliable on-farm outcomes, and finally provide for continuous learning and optimization. And as I said, recently this year we received the green light and the endorsement by CGR as the one system under CGR for breeding data management. And more you can read more about it. Hopefully you receive access to this presentation, and you can access that piece of communication through that link. Next slide, please. So what is going to happen in the future? And by future, I mean it's happening now, but it's the work we are doing is focused on a few changes for 2024. So EBS has become part of the breeding, initially has become part of the Breeding Resource Initiative, which now is establishing a breeding research services unit under genetic innovation. And within this new structure, we will have a breeding IMT, a breeding information management technology area, which will be the ecosystem for the EBS. So as you can see on the screen, we have an initial preliminary structure that we are proposing. We are doing some refinements for 2024, but roughly this is what we will look like starting 2024. So EBS will be hosted and probably the flagship of this structure, although we will be responsible for some other projects related to breeding IT. But EBS obviously will be the major one hosted by this new structure. So this unit will be responsible since the beginning of the initiatives for making smarter use of more data. This is why EBS is part of this structure, has become part of this structure. And our team, the EBS team, as I mentioned, will become the breeding IMT team to provide support, to provide solutions related to breeding information management technology. Next slide, please. And here are the vision that we have created for breeding IMT. We are the CGR's core provider of breeding IMT cost-efficient solutions, operating at the highest industry standards. So that's basically what EBS is, using the highest standards and promoting cost-efficient solutions for CGR in terms of breeding operations. And our processes include, of this unit will include running and maintaining the solutions. So as we are moving EBS into a new phase, we will continue to keep it running, of course, but also to provide new functionalities based on what we know so far that the crops and the users are expecting to have, but also based on new requests, new feedback from the users. And we have a dedicated team just for adoption and user support, with a service desk, with a team to provide training and documentation and all of that. Next slide, please. I think that was my last one. Yes. So now I will pass it to Kate. Thank you, Kate.
Thank you, Andre, and thank you for the opportunity to speak to all of you today about the enterprise breeding system. I'll be trying to provide a little bit of an overview of the functionalities. As Andre mentioned, it's designed to be a comprehensive system to support the needs of breeding networks. And to do this, the EBS is composed of 4 different domains that you can see here: core breeding, service management, core system, and analytics. In the interest of time today, we'll be focusing primarily on showing some of the features that are available in the core breeding domain, perhaps with a hint of analytics if time permits. But before we dive into the system, I just wanted to point out some terminology that may come up in some of the applications, in case it's terminology that may be different from some of the vocabulary that's used in other systems or in other crops. So we'll talk a little bit about germplasm and experiments in the EBS. So to start, for germplasm concepts, the EBS maintains information about germplasm and inventory at 3 different levels. The top level of germplasm provides information about any genetically definable material with a pedigree or a name. It could be an inbred line, a hybrid, or a landrace. Below that, when germplasm is harvested, especially if a germplasm is harvested multiple times, then multiple different seed lots can be generated that provide information about different origins of that same germplasm. And in addition, after seed is harvested, it's stored in physical entities that are referred to as packages. A particular seed lot could be stored in one package or could potentially be divided into different packages that could be managed by one or more breeding programs. And so this information provides, or these three levels provide the ability to provide traceability for inventory within the system while maintaining important information about germplasm as well. Another term that I'd like to describe is experiments. Within the EBS, an experiment refers to any trial or nursery. However, the activities are not carried out directly at the level of an experiment, for example, having a plot list. Rather, that would be handled at the level of an occurrence. So each experiment is linked to one or more occurrence. If we take the example of a nursery where perhaps you're just increasing seed, that experiment would likely only have one occurrence with it, where you plant all of your entries and then harvest the seed. However, in the case of a trial, we would typically expect that one experiment would be linked to multiple different occurrences to be able to look at the performance of the germplasm in different sites and or different environments. So you'll see these terms experiment and occurrence in the interface when we look at some of the current functionalities that are available in core breeding. So to do that, I'm going to turn off the PowerPoint and enter the system. The system that I'll just be showing a few highlights from today is actually an environment known as the demo environment. And it's an environment that's available to the general public. So all of you and anyone else you know who might be interested in looking in more detail at the functionalities of the EBS can request an account in this demo environment, and we'll provide a little bit more information about that in the future or later in this presentation. So when you log into the system, you're able to see information about one or more breeding programs or teams that you're a member of. Within this demo instance, it is both multi-program and multi-institutional. You can see that we have some example data from maize and from wheat and from rice. And also within this environment, importantly, there's a collaborator program, which shows one of the ways in which the EBS can be used to support network breeding, where collaborators, for example, who are involved in phenotyping networks, can also contribute data to an EBS instance. So one of the ways to highlight some of the different functionalities that are available in the core breeding system is just to mention the key tools that are available within the system that are displayed on the left side of the screen. So experiment creation allows users to create their trials in nurseries, and then experiment manager enables them to perform many other activities associated with those trials in nurseries during the season. There's a tool for planting instructions that helps users to set up their planting jobs and to make substitutions for entries, for example, if insufficient inventory is available. There's a specialized tool for enabling users to make crosses within the system, as well as a tool to facilitate data capture and the upload of data to the EBS. Another tool helps to support harvests from, in particular from nurseries. There are two tools that are available to allow users to access information about the germplasm and the inventory that are stored within the system. And there's another tool that enables users to perform some inventory management activities. There's a catalog of traits, and then there's a tool that enables users to manage lists. That could be lists of inventory, lists of germplasm, even lists of plots from nurseries that need to be genotyped, for example. So to look at the tools that are available within the system, we can just get a brief glimpse at the start of a breeding cycle, which would involve creating experiments, trials or nurseries. Pardon me, it logged out while I was showing the other presentation. Okay, so if we go to experiment creation, this tool allows users to create both trials and nurseries. One of the features of experiment creation is that when you start to create an experiment, you have to select the type of experiment that you would like to create, which enables the software to set up a workflow that guides the user to provide all of the necessary information for that type of experiment. So for example, if someone were going to set up a breeding trial within the system, we can see the different activities listed across the top here. First, some basic information has to be provided, then an entry list, and then importantly within breeding trial creation, a design has to be either generated or uploaded to the system. Additionally, information about protocols can be added. and sites can be assigned to the different occurrences for that particular trial, and then the experiment can be reviewed. To show you an example of what a work in progress experiment creation would look like, I have another example of a different workflow, which is an intentional crossing nursery. This is a type of experiment where at the beginning of the season, the user knows what crosses they would like to set up. One common example of this may be in hybrid breeding, where at the beginning of the season, members of a breeding program are setting up crosses for hybrid formation. So in this workflow, users are able to put in basic information such as the year of the season and the relevant pipeline. They're then able to input an entry list of the parents that provides information at all three levels that we saw previously. So we can see information about the germplasm, information about the seed origin, and even information about the specific package to help ensure traceability of all of the germplasm and activities. And in the case of crosses, the role of the different parents can be specified. The users are then able to set up the crosses within the system and to specify how the parents should be planted in the field to facilitate crosses, for example, by interspersing repeated parents between other parents in the nursery. Users then have the option to add protocol information, such as the plot size, perhaps pollination instructions, any traits that they may want to capture about maturity, etc. And then finally, in this case, as it's a nursery, there's only one occurrence, and the site for that occurrence can be defined. In the case that it's in a breeding station, perhaps even a specific field could be assigned to this nursery. In all of the workflows, the users are given a final chance to review their entry list to make sure that it has all of the correct information. And also in this case, as crosses were set up, the users also have an opportunity to look at their crosses before completing the creation of this experiment. So that's a very quick example of how you can set up an experiment. Once you do complete the creation of an experiment, the experiment will then show up in the tool that's called Experiment Manager, which enables users to perform many additional activities during the season. And it's also a place where they can look in more detail at the field books for all of their trials at nurseries. So, for example, here is a nursery that has been set up. Users can look at the basic information of any of their trials or nurseries. They can see an electronic field book that provides information about the germplasm. In this case, this is a nursery that has several F4 lines that will be advanced to F5s. Again, you can see information about the source seeds and packages. Users can also see their plot information within Experiment Manager, including any data that have been uploaded to the system. As this is a nursery, we can see information about the harvest date of these plots, the method of harvest, and as this is a maize example, the number of ears that were selected. So this is a centralized place for all of the information about this particular nursery. And as I mentioned, the Experiment Manager enables users to connect to various different tools. In this case, for example, as this is a nursery, we may want to harvest it to generate new inventory at the end of the season, or a new germplasm as well. So we can, in this case, go to Harvest Plots, which then brings us to this Harvest Manager tool. For the sake of expediency, I've already harvested this nursery. We can see the information about the different materials. And then at the end of the harvest, new germplasm in this case is created, new F5 germplasm. Information is available about the harvest method for that germplasm. New seed lots are created for each of those, as well as new packages. All of these are then available within the system for use by this program. And another important feature of the EBS is that it really does facilitate germplasm sharing between different programs that can be within or potentially across institutions. For example, after harvesting materials, a user can save a list, and then through the Inventory Manager tool, if the user wanted to share some or all of that seed with another program, they can set up what's called a seed transfer, where they can share packages from one program, for example, the early maturity maze, to another program within the system. So this helps to facilitate work across different teams. So that's just a very quick example of a nursery, just to give a very brief introduction to what trials look like. This is an example of a trial in Experiment Manager where we can see that one experiment is associated with 4 different occurrences. We can also get a quick view using the statuses of different activities that have happened for these different occurrences. 2 of them have just been planted, while 2 of them have trait data collected and have even had their data go through an additional level of quality checking that would make them ready for analysis. So again, for these trials, we could look at the details of them by clicking on the eye icon. And this is also a way that we can interact with the data capture tools. So from Experiment Manager, users can start the process to initiate trait data collection. The EBS works very well with the PhenoApps Fieldbook app that I think many other programs are familiar with, to facilitate electronic capture of data in the field using traits with defined values, valid value ranges, and scale values to support good data quality, although the system can also export files that could be connected to other types of data capture devices as well. Once the data are ready to be returned to the system, users can then go to upload the trait data. This gives them the opportunity to upload data from Fieldbook or other devices that can export CSV files. Once they upload that data, they're then able to see it within the system and to do a preliminary review that highlights the general statistics that might point to any potential challenges with the data. And at the plot level, users are also given an opportunity to see, for example, highlighted values that are considered invalid. For example, with a disease score rating of 1 to 9, a value of 12 would be invalid. Or if we're looking at the ratio of ear height to plant height, something above 1 would also be invalid and may indicate that the input data values were switched by accident for this plot. In this user interface, users have an opportunity to potentially suppress bad data values, or even if they know the correct data values, to correct them at this point before they're added to the system and become available within the electronic field books online. Just to highlight quickly, given the importance of having high quality data available for analysis, after the data are loaded to the system, there's another tool that's available in Breeding Analytics to give the users the opportunity to look at the data in more detail, called Phenotypic Data Manager. And so I'll just give you a quick sense that once data have been loaded, it's possible to go look at the data with another cool tool called Phenotypic Data Manager that can do some additional functionalities, such as highlight possible outliers that users can then suppress. And it also gives some more visual ways of looking at the data to identify potentially problematic data that should be suppressed before going to analysis. So there are various different ways to sort of look at the data to try to ensure that it's clean or as clean as possible before going into analysis, including looking at heat maps if the field coordinates have been provided. So I think that's a very quick introduction to some of the many, many functionalities that are available in the EBS. The good news is that you can look at all of these functionalities yourself if you would like to get access to the demo environment, look at these functionalities and more. So at the end of the presentation, we'll put this into the chat. So anyone who would like to access this system can look at the tools. And while you're there, if you have any questions or need any additional information, you can navigate to either the user guides that provide more information about all of the tools, and or you're very welcome to submit any questions or suggestions or comments to our support desk. We have team members around the globe who are waiting to try to respond to any questions as quickly as possible. So with that, thank you for your attention, and I will turn it over to the next speaker, Marko.
All right, it's my turn. Hi, everybody, wherever you happen to be. I hope you're having a wonderful day. Thank you, Kate. Very, very brief but comprehensive demo regarding some of the capabilities and functionalities that we have implemented in EBS. So we have been operating for several years. Oh, by the way, my name is Marko Kärkäinnen, and I'm a product lead of the EBS. For you that haven't seen me before. But yeah, I'm giving you just a high-level update about where we are right now. Like you saw from that demonstration, EBS is ready to go from end to end, and that has been accomplished through milestones. Now, milestone 8 will be completed in December, and it pretty much means that the breeding teams can handle the end-to-end process on breeding data management. With end-to-end, I mean the fact that they can go from beginning of the breeding scheme to the end. So crossing, nurseries, trials, and so forth. So all those breeding stages are supported. And within the season, breeders can create their experiments, manage their experiments, collect the phenotypic data using handheld devices and other ways, harvest the material so the advancement can be done and the pedigrees are written to the database if needed, and then analyze the data using their breeding analytics. So that's pretty much where we are right now. In addition to that, if we go to the other domains in core breeding, we have workflows for material transfers like the internal seed transfers, and operational genotyping and seed inventory workflows. So that's what we have in our hands by the end of this year. Then let's talk a little bit about the future. Next slide, please. So now that we have a fully operational breeding information management system in the hands of our customers, the work doesn't end there. Everybody that has owned a car knows that the car needs service. If you don't change the oils and the engine will first start to damage and then completely die at some point of time. So that's why any kind of information system needs continuous improvements to keep it up and running. So the objective really is to enable smooth operation and satisfy customers because of that. So it means that there needs to be regular maintenance work that needs to be done on source code level, keep it up and tidy to ensure that there are no bugs that prevent usage and so forth. And along the way, EBS has been under development for quite some time. We started 2018. So some of the requirements that were gathered and implemented back in the day, perhaps they are out of date and need to be changed now when business has changed. So there are always going to be a need to improve the existing functionalities that we have been developing over the years through business needs or perhaps missing requirements in the beginning and so forth. So that part is our operations. And then to ensure that the development when it takes place can be efficient and whatnot, we need to keep the development environments up and running and keep the technical documentation up to date and available. So continuous improvement is an important part of our future. And next slide, please. Then, in addition to the existing capabilities that we have provided that allows the go from end to end from breeding scheme and within the season, we like to extend the functionalities in both ends. So that green box over there is the current version that we have in our hands right now. Like I said, we will continuously improve based on the customer feedback and if there are changes in the business processes. But especially emphasis will be on digital data capture. Right now, the turnaround time of the data within the CG is quite bad. At best, we are talking about days. And the turnaround time of the data, I mean in this context that when person is in the field and measuring an observation, for example, the time that it's used in actual decision making is at best days. And sometimes it's weeks. And in worst case, it's months. So we want to be able to help with that by developing capabilities that will allow the turnaround time of the data to shorten from months or weeks or days to one business day. So if something is measured today, we want to be able to use that in decision making tomorrow. So that is our ambition going forward with the digital data capture. There were also some outtakes from the original EBS scope from various reasons, and those capabilities we would like to develop, like Trade Data Manager, Trade Manager, for example, and integration experiments. Those outtakes from original scope would be part of our future implementation. But then completely new capabilities. In the beginning of the process, Breeding Program Manager. So all of you are in position perhaps where you are running budgets on your breeding programs and deciding what's in the pipeline and what are the target varieties and so forth. So we are building a capability that where you can manage your breeding programs. What are the breeding schemes? What are the pipelines? What kind of control varieties are used on those pipelines, and so forth. And they will then link directly to experiments so that we can use that information for reporting, for example. And providing visualizations or standard reports that allow the breeder or the lead breeder to evaluate that how well or not that well our breeding program is actually operating based on the data that is in the database. Then we have the first wave of our breeding analytics, quite simple at this point of time, single occurrence and multi-occurrence analysis. People want to, of course, build more. So more phenotypic data analysis, more molecular data analysis, and provide interoperability to solutions that are not part of EBS. So that's what we want to do for breeding analytics. Then those results from the analytics are used in the decision making. So every year, breeders will have these advancement meetings, and right now, our understanding is that the work that is done to gather the data, to create the data, to combine it and format it and so forth, it's manual and very, very tedious process and slow one, and probably full of errors, possible errors. So we want to build a capability that facilitates the advancement meetings so that the breeders can use that solution when making decisions based on the data that has been collected throughout the years and analyzed, and then store that information to the database as well, so that when breeder leaves the program, the decisions made are actually available to the next one. So continuous operations is also part of the plan in advanced meetings too. And then some of your breeding programs, you share materials with your colleagues. So to facilitate the data sharing, that these are the best parents, for example, that we have created in our breeding program, or these are the new elite materials that we have produced. They can be shared with your colleagues within the CG through EBS. And then for reporting, donors, lead breeders, crop leads, they all need to be able to know what's going on, how well this pipeline is performing. So we are planning to develop a dashboard that visualizes, provide different type of visualization about what's the performance of the breeding pipelines or the whole program in general. So those are the highlights that we are proposing to develop and deliver in the future. Next slide, please. Then milestone 8 and even previous versions, we have provided a lot of design capabilities for different operations. So breeding operations, material transfers, operational genotyping, as Edie inventory, for example. So we have worked with the subject matter experts and gathered the requirements and implemented workflows that support these operations. So the next step really is to broaden our customer base and work together with other crop programs that we haven't worked before, and process teams, and really to identify that is there something that actually blocks the adoption, for example, of material transfer pipeline in EBS. And of course, then when we have identified the blockers, we address the blockers, we fix them, we improve the system so that the new customers can start to use the system and roll out those operational processes in their own institutes. So the crops and new operational processes. Next slide, please. Yes. So this is the last slide I have. So Up until now, our customer base has been quite narrow. We have been working together with our EBS is used in Simit and in Erie and Africa Rice, and Icada is adopting that as well. Edie will talk later on more about the adoption, but our ambition is to enable the large-scale adoption of EBS in CG and NARS. And that means that we need to work under the hood. For example, that when an organization decides that EBS is the right solution for us, the first things to do would be the data migration. Everybody has the legacy system that they are using right now. So building and facilitating the data migration by building a pipeline that can be used to migrate data from legacy system to EBS, and even the historical data that is not operational to a data lake system or something along those lines is part of our ambitions. We want to cut the costs so that the same infrastructure in cloud infrastructure can be utilized in multiple different customers, so that the cost per customer would be lower. And then across the crops. So right now we have been tested with wheat, maize, and rice. We are working with legumes, but other crops should follow. And of course, we are a global organization, and there are a lot of languages that people use. So EBS probably should be a multi-language system to facilitate the adoption. Thank you very much. And now to Edie.
Thank you, Marko, and also to you, Boja, for organizing this information session. So my name is Edie Paul, and I'm the lead for adoption and change. And I just want to give you a very brief overview of our adoption pipeline and the process. So as other speakers have mentioned, and you've seen through Kate's demo, EBS is really a full-featured platform that's being used by a number of programs to manage their breeding operations. And some of these programs have been doing this for close to 2 years. So the point is really that EBS isn't a beta version software or a test version, it's a production-ready platform. So this is a snapshot of our current pipeline. On the far left are those programs that Marko was just referring to that are using EBS to run their operations. So the CIMMYT and IITA maize programs, CIMMYT wheat, Africa rice, and Erie rice. In the next box over, we're currently actively working with the Icada wheat program and IITA soybean and cowpea programs. And right behind that will be Siat rice. And then Erie is working with 2 of their key NARS partners, Phil Rice and the Bangladesh Rice Research Institute, to bring them on board. And the last box, we could fill that with many more things. We've had lots of interest from many other programs, from other NARS partners, from several private sector companies and public institutions outside the CG system. So the point is there's certainly a growing awareness of EBS and what it can do. So next slide, please. So this graphic shows the general stages and flow of the adoption process. And the green steps are the responsibility of the adopting program with support from the breeding IMT, and the blue steps are our responsibility with help and support from the breeding program. So before adoption really formally starts, the breeding program can do some things that will make the process go more smoothly, like collecting and cleaning your data, getting it in a standard format, and especially identifying and allocating resources that will be able to help with adoption. Then the global user support team will get involved and work very closely with the key people from the breeding program to learn more about the program, the data, to understand your workflows, identify this, what we call the minimal viable data set that needs to be migrated to allow you to run your operations, and to come up with a migration and a training plan. And as Marko mentioned, if this is a crop that we haven't supported yet, this step would include identifying features that are unique to that crop, and getting the requirements documented. At this point, we need several people from your team to be involved in this process. Once the migration plan is defined, we can start the migration process, which is really extracting the data, migrating it, and then validating it for this target data set. And again, this needs several people from the breeding team to be involved, especially for validating the migrated data. And during this process and beyond this process, training of your key users, so your early adopters, data managers, support people can be happening. Once the data is migrated and validated by your subject matter experts, a production instance, production database can be deployed. And again, as Marko was talking about, throughout all of this, the process of continuous improvement of the software is occurring. So as your program goes through all your workflows and starts using the system, if you have suggestions for improvements or new requirements, they get entered into through our support desk and passed on to the software team for review and planning for implementation. Then once the production instance is made available and your key users are trained, the ball is officially rolling and the continued adoption is then managed by the breeding program. Next slide. So some key points about this. There really is no one size fits all for adoption. We can't say this takes exactly 6 months. Or a time frame. There are a lot of factors involved, including the data volume and the condition. Is it in a coherent legacy system, or is it in a bunch of Excel spreadsheets on all the different breeders' laptops? Also, the capacity, the commitment, and preparedness of the adopting program, and whether you are merging into an existing instance, so a shared instance with other institutions, or whether you're going into a new instance. So all these things affect how long the process will take. We are working, however, as we do this with more programs, we're hoping this becomes more standardized. And full adoption takes at least one full growing season. So we would hope that you enter this process with the intention of stepping through all your workflows and as you go, identifying the issues along the way. As I said, these get entered into our tracking system, passed off to the continuous improvement team, and if fixes or enhancements are needed, they get included in the planning for future releases. And finally, adoption is not a passive process. We can't come in and wave a magic wand and make it all happen. It will take time and commitment from everyone, from your team and our team. And the more engaged and involved the breeding team is, the better the outcome will be. So we certainly look forward to working with your teams when you're ready. And in the meantime, as Kate mentioned, there's a demo environment that you can sign up and have access to if you would like to test out the interface, play around with it, etc. Next slide. So I think that's the end of our formal presentation. We thank all of you for taking the time to attend and listen, and again to Boža for helping to arrange it. I know this was a lot of information and detail that got tossed at you, but we're happy to go back and revisit any of the slides or any topics or answer questions. And I'll turn it back to you, Boža.
Thank you so much. Thank you, Edie, and thank you all the EBS team, all the presenters today. This is a wonderful presentation, wonderful session, and thanks for making it happen in short notice, because we discussed about this just 1 week back, and we're very happy it happened. We could make it because so next session will be in December, so we're not sure that time the participation, all those things will be towards the end of the year. Anyway, so we have very few minutes left for question and answer. If you have any question and if you want to ask by yourself, please raise your hand and feel free to jump in. And I again, this is an opportunity for all of you, to to ask questions, any concerns, and anything about EBS. Please raise your hand, jump in, unmute your microphone. And I can see a lot of discussion going on in the chat, a lot of useful discussions. And I don't see any, if there are any unanswered questions there. I'm not sure. So I think most of them.
I'm sorry, I can't see how to raise my hand. It's Gary. Could we get
Gary,
somebody to comment briefly on the vision for genomic data, how we're going to do genomic selection, and how we're going to do selection on the basis of haplotypes? How will the genomic data be linked to the system and accessed by the breeders?
I can take that. So right now we are working or have implemented the first version of the operational genotyping, which is the starting point, of course, so that the plants or the seeds can be sampled and genotyped and then sent to vendor, and vendor returns the results and they are loaded to the database. So we have that. The next step will be to integrate that genotypic data to molecular analytics tools and then on other analysis use cases that are needed. For next year, we will prioritize what are the analytical use cases and go with it. That's the simple answer.
Thank you, Gary. Bodo, please go ahead.
Yeah, thank you. So it's very nice, and I see there's a lot of progress, and it looks to me it looks very appealing. The question is, I am in touch with very many breeders in Africa, and in particular in West Africa, and not only with CG breeders who are privileged because they get this support somehow pre-prepared. But when the Naris, so when I meet the Nari breeder, let's say a rice breeder in Ghana or so, and he says, what data management system to use? And I say, okay, there's EBS that is coming up, and he says, okay, what do I need for it? And then what can I do? Can I recommend them to go to a website, download the program, and start working with it, trying it out, see how it fits, or what recommendation would someone give how to get in touch with the software?
I do think
EJ,
a good
I
starting.
was going to suggest, yeah.
A good starting position would be to go and sign up for access to the demo version, and also probably to start looking at the user guides to really get an idea of the capabilities that are there, and a feel for what the interface looks like. I think that would be a good starting place. And if they want to start discussions with our team, I believe there's a link also on the support desk to ask questions about adoption or any other topic they can ask on the support desk.
Thank you. Sounds good.
Thank you. I can see one question from Godfrey. Godfrey, if you are there, would you mind to jump in? It would be nice to hear from you directly with your question.
Yeah, okay. One of the challenges which I find, and probably most breeders find, is that, this database program, you do a very good job, you get your output, but to take that output to the seed storeroom is a challenge. You can't print it, you see it's nice, you can't print it, you have to export it to Excel, then you start creating templates for you to be able to print. And this is probably one of the main reasons breeders are still so much attached to Fieldbook, because it has already templates, which is like you can click, you have a template, you can tweak around in Excel, and then you can print your envelopes, you can print labels for envelopes, plot labels, and so on. But with other database program, it's very difficult. You have to probably have a bartender for you to be able to go print, create templates, and so on. and it discourages breeders to adopt those programs. Because it's like you have a good everything in your system, but you can't take it to your seed store, you can't take it to the field. Then it becomes very difficult. So what I'm doing with EBS in terms of printing labels, in terms of printing labels, special labels, what are you actually doing regarding that? Well, that's an area where I think if you want adoption to be easy or to be adopted very fast, if you have easy of printing the labels, then it's easy for people to adopt it.
Marko, would you like to address that, or would you like me to answer?
Well, yeah, I'm not sure if was that a question, but what I can say is that EBS has a very, very feature-rich printout service. So we have a label editor that can be used to create any kind of labels or standard templates and so forth. So we work together with the breeding teams to understand that what are their printing needs, and then we create the templates for them, and then they can access them directly from the system. So that's what we have, but hopefully I answered your question.
Kate, did you want to add anything?
No, thank you. Just I apologize that I didn't show that during the demo, because it is quite easy from various different tools. Wherever you see a printer icon, there can be customized printouts that a user could use to print envelopes, field tags, etc. So I apologize for not showing that.
So I have a not last, but my question from my side as well. And I can see Andre answered that question, but still it would be nice to hear from you directly here. So what's the plan, the next plan, if some other breeding programs, we can see the adoption plan very clearly, and that's very nice, that's encouraging. So what's the next step in terms of comparing the capabilities with other systems like BMS and others, so that the prospective users or the ones who are thinking to adopt EBS in the future, do you have any plan to have detailed analysis, compare side by side, and go through those and make it available to the people who are interested to learn more about it, in the future?
Okay, I can take that one, but Marko, Edie, Kate, feel free to jump in. So related to breed base, so we have these three major systems under use under the CG. So EBS, and then we have BMS and breed base. So with regards to breed base, this comparison, this requirement analysis exercise is going to happen next week in Kenya. So we have put together a large team. Marko is leading that in partnership with Tusha. So people like Lucas Miller and others will be participating in that, and hopefully we will get the objective achieved by the end of the next week, which will be a full list of requirements that need to be over time implemented in EBS. So RTB crops can easily migrate from breed-based to EBS if that's the decision still to be made. But we are doing it anyways. We will be enabling those functionalities in EBS anyways. With regards to BMS, that exercise, as I put in the chat, was done some time ago. And that's why exactly we started with the transition from BMS to EBS and not breed-based to EBS. So we thought that EBS was going to be able, and it is able, to replace most of the functionalities. It was and it would be a more straightforward exercise from BMS rather than breed-based, which has started to happen in 2021 for some of the BMS users under CG, and that's also happening for some of the NARs starting next year who are using BMS. As I also mentioned in the chat, something might have changed in BMS over the last years, of course, because they keep delivering new capabilities. So it's a matter of us setting ourselves to do a new requirement analysis of BMS and a kind of a comparison to see if we're missing something or what we are missing. We're probably missing a few things. Of course, there's no 100% match between systems. It wouldn't make sense to copy one system because we offer other functionalities that the other systems don't. But in the future, we can of course try and match those missing capabilities or missing functionalities that we haven't done yet. So it's basically like we are planning to do for grid-based next week, and for BMS we can do a review of what we've done in the past early next year just to check what's missing and try and implement them. But as I also mentioned in the chat, we have very good feedback from the users who migrated from BMS to EBS, and we have a mechanism that we intake feedback from the users, and then we prioritize the new requests as part of our roadmap, and based on prioritization from the users and from our main stakeholders, we sooner or later we end up implementing those capabilities in EBS. So that's basically how we are planning, or how we've been doing over the last years, and we'll keep doing over the next years as well.
Thank you, Andre. We're running over time, but still, because it looks like a lot of interest is there. So if you don't mind, I'd like to stay, few more minutes, 2-3 more minutes, if that's okay with the team. And we have a hand from Patrick. Please go ahead. We don't hear you, Patrick. Looks like there is an issue, the microphone. At the same time, again, Gary is, he's raising the important concern about the integration of genomic data in the system, and that I think that's a valid point.
I am a bit concerned
Gary.
that wasn't addressed at all in this discussion. The ability to select on the basis of specific haplotypes to create an entry list, I think, needs to be a core functionality. I presume that's planned. But the ability within standard breeding operations to calculate the genomic relationship matrix and a GEBV from a set of materials is a core function that's required now, right? It's the core job now of NARS CG breeding networks. So I imagine you're thinking about how to do this as advanced, but it's important that you share it with the users. I think this area is evolving quickly, and so we need a live conversation on what the plan is for developing interim capacity that's needed very quickly, and what needs to be built in as core functionality in the medium term. So if you can give us a bit of a picture of what your vision is for that, then we can assess whether we're moving in the right direction. If you're not ready to do that, it should be the topic of our next meeting.
Marko, is there anything else you would like to add, or can we maybe consider this for a next meeting as a topic?
Yeah, I would say that the next meeting would be, I don't want to throw Eduardo under the bus, but he's the BCM of breeding analytics in EBS, but we didn't ask him to prepare anything for it. So I would assume that the best would be to discuss this about next time around.
Sure, and let's make sure that next time is quite soon.
think now, yeah, we're 10 minutes over. So we have to stop now. And thank you once again to EBS team for your time today, for this wonderful presentation, and all the participants. Thank you all. And please, EBS team, share your presentation with us, and we are going to share this presentation and the recording to all the other participant lists in the for this community of practice list within few days. So yeah, thank you, and then we'll see you in next month. Thank you so much.
Thank you. Bye.
Thanks, Boja. Thank you, everyone.
Everyone. Bye. 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 Thank you.